Unit 4, Lesson 6. Here we are almost to the end of our exponents. We are going to talk about some applications of exponents and what to do with graphs and word problems. So we're going to look at equations for exponential relations. Remember from previously that an exponential relation has an equation that looks like this. Y equals a b to the x. A is the initial value. So that means what you start at. B is the rate of growth or decline. So that's what you're multiplying by. So that can be a number larger than 1 if it's growing or less than 1 if it's decreasing. So we can determine if a relationship is exponential by looking at a table of values and looking at the successive y values. So the y values in order. So we're going to look at these two tables and we're going to decide if they're exponential. So I look at this table and I notice from 10 to 12, 12 minus 10 is 2. And 10 minus 8 is 2, and 8 minus 6 is 2. And I remember from earlier on in the year, when all of those subtracting, they're called the first difference. And when all the first difference are the same, it means that it is a linear function, a line. You're going up by the same amount. If I look at B, I can tell just by looking at these numbers that they're not going up by the same amount, because 9 take away 3 is 6, and 27 take away 9 is going to be more than that. So I know that it's not going up by the same amount. The other thing we can do is divide. We can take and divide the two numbers. So 729, let me change that. So I can do successive y values, 729 divided by 243, and I'm going to get 3. And I can do the next two, 243 divided by 81, and I get 3. And I can do 81 divided by 27. Oh, and I get 3. Oh, I think there's a bit of a pattern here. If you divide instead of subtract your y values and you get the same answer, that means it's exponential. Scroll down a little bit and write that down. So when you divide and you get the same answer, the relationship is exponential. It's an exponential relationship. Let's move that down a little bit. So exponential relationships involve multiplying patterns, and linear relationships involve adding patterns. So you're increasing by the same amount if it's linear, and you're multiplying by the same amount if it's an exponential relation. So that's how you can tell the difference from a table. If I have a word problem, I can use this idea of multiplying by the same number to figure out the rate of growth or the rate of decline for our equation. Remember our equation, y equals a b to the x. That's what you start at, and that's your growth, your rate of growth or decline. And this rate of growth or decline comes from dividing your y values. So if I look at my table, I see that I start at 55.6. So that will be my A number. Then to figure out my growth, I'm going to check to make sure it's exponential. So I'm going to divide all my y values. So 84.4 divided by 76 is 1.11. And 76 divided by 68.5 is also 1.11. And I'll do the next couple. 68.5 divided by 61.7 is 1.11. And 61.7 divided by 55.6 is also 1.11. So that means to write my equation, I will have y equals my starting number of 55.6 times my growth rate, which is the answer to my dividing. So that means I'm growing, slide my down a little bit, that means I've got 1 plus 0.11. So I'm growing by 11% each year according to the table. All right, so there's our equation. Other thing with your equation, you got to say what your letters stand for. So you go back to your table. This is your x, this is your y. So if my equation is y equals 55.6 times 1.1 to the exponent x, my x is the years according to the table, and my y figures out the price of gas, I believe it is, per liter. Next part, determine the price of fuel per liter after 15 years. So it's telling me the years, and the years are my x. So I go back to my equation and I take out my x and I put in 15. And I get out my calculator and I figure out my answer. So I'm going to have 55.6 times 1.11 to the exponent 15, which gives me, so let me double check that, 0.6 times 1.11 to the exponent 15. $266.02. All right, let's look at one more example. Table shows the height of a ball after a number of bounces. Use the information to determine an equation for the height of the ball after x bounces. Sketch the graph of this situation. So, our equation pattern, starting value, what it's growing by. There's my starting value. And to get what it's growing by, I'm going to divide. 79 divided by 107. 79 divided by 107 is 0.74. And then I'm going to go 107, whoops, 146. 7 divided by 146 is 0.7374. 146 divided by 200, 0.73 it looks like. I think I rounded wrong. Double check the last one, divided by 107, 0.74. So it's about 0.73. So notice that it is less than 1. That means the height, or whatever the word problem is about, is decreasing if it's less than 1. Unlike the last one that was 1.11, and we talked about how it was growing. 1 plus 0.11, it's growing by 11%. This one's less than 1, so the height is decreasing. So if I write my equation now, I have y equals, my a value is 200. I'm multiplying by 0.73, and I have my x. And if I go back to my table, my x is the number of bounces, and my y is the height in centimeters, the x and the y. And I need a little bit more space here because it also asked me to sketch the graph. So if I'm going to sketch the graph, I don't have to do a super big graph, but I do have to know that 0, 1, 2, 3. So that's the number of bounces. And I'm going to start up here at 200, rough scale, and that's the height, centimeters. And so when I go to graph this, at the beginning it was 200 centimeters. After one bounce it was 146. After 2 bounces it was 107. After 3 bounces it was 79. And we can see that exponential shape start to take hold. So if you think about a ball bouncing, it started up here, it hit the ground, and it came back up. And then it hit the ground, and it came back up. And then it hit the ground, and it came back up. And the height decreased at the number of bounces. Determine the height of the ball after the 7th bounce. So x is the number of bounces, so I get out my equation. And we said our equation was 200 times 0.73, and x is the number of bounces, so I put 7. And I get my calculator out. And I get my calculator out and I type it in. 200 times 0.73 to the exponent 7, and I get about 22.1 centimeters. So therefore, the ball is about 22.1 centimeters. All right, so that is word problems and writing equations. You're going to try to do those questions, and we have one more lesson in this unit.